Okay, welcome class. Today I'm going to walk you through a short video talking about some of the basics of data type conversion in C. This is an important topic because data types, as we've seen before, are used throughout all programming languages. Different languages handle it differently, but different problems require different types of data, and a common issue is trying to, based on solving certain problems, having to convert between one data type to another. Right, so we'll look at some common ways of doing this. In particular, we'll focus on some of the nuances in C. And what I mean by data type conversions is you can think of it as going from, say, like a string to an integer, or from an integer to a double, or these types of different operations. You'll notice that there's a couple different ways of handling it, and you're going to, throughout pretty much every program you ever write, once it gets beyond a certain size, you're going to have to be mindful of how to convert between different types of data. Okay, so first, just kind of setting this up, it's important to note that there's two different types of data conversion. Okay, one is implicit. The implicit type of conversion is the one that the language just allows the conversion to happen. Okay, and we'll look at some examples of how to do this. Okay, so some examples could be, say, going from an int to a double. This conversion is pretty straightforward because what happens is, double actually has twice the number of bits available. It's just going to basically represent it as the same number, but with a zero for the after the decimal point. Okay. Another example is going from a double to an int. This is a little bit more dangerous because that type of conversion typically has some data loss associated with it. So, for example, when you go from a double to an int, the risk there is that you are going to drop the fraction. It's not going to round. It's going to drop it. So, for instance, 4.9 does not become 5. It actually becomes 4. The decimal just gets thrown away. Okay, so those are implicit. We'll look at a couple examples in a second in terms of what that looks like from actually writing the code perspective. But it's important to note, kind of as we're setting this up, that there's different types of data conversion, and some that are not just kind of done in a more of an automatic way with implicit conversion. That's the explicit conversion. In that case, the programmer directly indicates that they want to change the type of data. Okay, so the example there is basically that the form of that is called typecasting, where the programmer directly indicates that they want to change the type of data from one to another. Okay, and we'll look at that as well. And through some of these conversions, we'll see how there's some functions that we can use to kind of help with the data conversion process. There's a few that are included in some common libraries that help us convert one data type to another. We'll look at those in an example, or a couple examples momentarily. Okay. First, let me kind of just show you when I talk about explicit data conversion, more particularly talking about a form of doing that called typecasting. All right, where the programmer is directly indicating that they want to change one type of data to another. We could see an example down here on the screen, and I'm going to plug this into the C compiler. Actually, run this code in a second. And the example that we see here is that, in particular, what this very simple program is doing is that we basically have some integers that describe the number of kids in a family. Okay, and as would make sense, is the number of kids in a family cannot be a fraction, right? It's going to be an integer. Right, you're not going to have 2.3 kids. It's going to be, it's going to be an integer, and we're basically calculating the average here. So we're going to calculate the average number of kids in the family, and that would make sense for that being a type double. Okay, because a fraction would be something that would be you would expect to happen, right, under most cases. All right, so here shows the example where it's actually being done correctly, where we are calculating it, and you can see that in parentheses here, there's a couple times where it's indicating that we're changing the type to double, okay? And then the end result on the left-hand side of the equal sign, that the type of average kids per family is already double, and we could see here that the output would be a decimal, right? That would actually be the expected correct answer, all right? That we have 3.5 kids per family based on the input data that's been provided, right? 3 plus 4, right? 7 divided by 2, 3.5. So that makes sense, right? That's what we would expect. All right, let me take this same example here and let's actually run it where if we did not do this typecasting, okay, we did not do it, and let's see if we can kind of look at the example and see what might go wrong if we did not kind of manage data types correctly. Okay, so I'm going to come back over here, and I'm going to say that we've got our kids in family 1, right? 3, it's an integer, kids in family 2, right? And we want to calculate the average kids per family. All right, I'm going to leave that without a value at the moment. Right, now we saw the example a second ago on the slide that showed the correct way to do it. I'm going to intentionally create a calculation that's wrong. Okay? And before I do the calculation, let me just think of the end result here. Is we're going to print a double, okay? And the double is actually not parenthesis, not percent sign D. That's actually for integers, but it's actually the double is a long float, right? It's a floating point number that's double the precision, right? So it's double. It's a double in this case. It's saying it's a long float is really the direct way of indicating that. Okay, so the long floats are double, and we're going to say we want to print the average kids per family. Okay, so let me go ahead now and do the calculation. I'm going to do it incorrectly, intentionally. Okay, so and I can actually place that right up here. Let's just see what would happen if I said kids in family 1 plus kids in family 2 divided by 2. All right. Now it's important to note, think about what are the data types here, right? We have an integer plus an integer, and 2 here is actually also considered an integer, okay? This 2 is also considered an integer. We could talk about how to actually make that look differently in a second. And I've got to navigate to the proper project, and I'm going to say GCC. It's the example. Okay, oh, let's see, I typed something in wrong. Oh, there's a typo here, as you probably already noticed. I need that Y. All right, it's showing that, you know, the error is pretty good. It's telling you directly which one is causing a problem. Let's compile it again. Okay, and let's just go ahead and run it. And notice it says 5, right? 5. So let's think about why that might happen. Okay, let's think about each step along the process. You know, what's going to occur, right? And actually, let's see if we kind of explicitly say that we want the order of operations to be here like this. Okay, so I added these parentheses here just to kind of make it a little bit more clear. We could talk about how the order of operations is affecting the result in a second. Right, so I'm going to go ahead, let's run this again with just that minor change. And notice that it's saying 3, right? 3. Now, why is it 3 instead of 3.5, what we would expect, right? Well, the reason is this is a type of integer, right? This is int, and this is int, right? So what happens is we actually do the following operation, right? We're going to say 3 plus 4, 7, right? It's an integer. That sum is an integer. There's nothing wrong there. When we take 7 and we divide it by 2, right? The end result is not going to be 3.5, right? Because the end result of an int divided by an int, right, is an integer, right? And as we saw on the previous slide, is an integer is going to throw the decimal away, right? So that 0.5 just gets tossed, right? Now we can look at a couple ways in which we can solve this. One, here's probably the simplest way in this example, is I can actually just say 0.0 here, right? That will make it a type double, okay? that adding that decimal will indicate that that operation should be a double. Now what would happen is it's an integer divided by a double will automatically result in a type double. All right, so double takes precedent there. Okay, double will take the end result will be of type double. I go ahead and run that. All right, notice that actually now we get the correct result. Okay, that's one way to do it. Okay, that's the implicit way to do it. This is an implicit example. It's done in the calculation. It's just done based on running the code. Nowhere in there am I directly indicating the data type that I want as the result. Okay, here's another way to do it. I could have left that as 2, and I could have said something like, you could do this a number of different ways, but I could actually just directly indicate that I want that to be a double. Okay. Right, this is called typecasting. This is the explicit way of doing it. Okay, so that's another way to do it. All right, so let's run that. Just kind of show you what I'm referring to. Right, notice that also gets the 3.5. By the way, if you don't want all these decimal points to come out like that, here's the simple way of doing it. When you do the print F statement, I could say between the print sign and the LF or long float, I can do dot and the number of decimal places that I want to display. Okay, if I did that, you can format it something that's more along the lines of how you're wanting to display the result. Okay. All right, so there in that example, we went through 2 different ways of doing data conversion. Okay, we looked at the implicit way where you just do the calculation, right? And based on how the calculation is set up, that it's going to convert the types for you, okay? And then we looked at the explicit way where you're actually indicating the data type that you want as a result. And so in this case, it's going to take that integer and it's going to flip it to type double, okay? And then do the calculation of an int divided by a double, with the double taking priority and that end result of that calculation being of type double, okay? Well, 2 ways to do it. Now, let's spend a moment just looking at a couple functions that can help us kind of solve some of these problems. Okay, so let's say here's a common issue is that we have a string. Okay, and a string, as you've already read in Zybooks, is a string which can be represented a number of different ways. I'm going to show it the simple way right now, is treating a string like a array of characters, okay? Just a whole bunch of characters, in this case limited by 256 being the max, okay? So I'm going to treat a string like an array of characters, and we could look at some operations that we can perform on a string to convert it from one data type to another, right? So first I'm going to just ask the user, using the scanf function, to go ahead and enter a string. Okay, just go ahead and enter a string, and we're going to put that result, right? This %s is indication that the user is going to enter a string, and we can even present like a nice display for them to say, to tell them what to enter. Okay, and say I want to convert that string to a number. Okay, here's some common functions to do that. One is doing a to I, right, where a is the symbol that's kind of indicating that it's a string. Okay, I know it's a little bit, you know, you gotta kind of remember that. Okay, and I is integer, and the end result of that operation is going to be a of type int. Okay, so we can use these functions to help us convert a string to a integer. All right, and other data types that we can look at in a second. And then what we can do here is we can say we want our string, right, as the input argument. Now, one thing you're going to notice is if you try to compile this right now, it's actually not going to work. Okay, and let me show you what the error message will look like so that when you see it, you can recognize it and hopefully realize what the solution would look like. Okay, so let me go ahead here and compile this and show you what I'm referring to. Right. So what we're seeing here is it's actually coming up with a warning, right? You want to take warnings very seriously. Warnings will compile, right? They will result in an executable. But what this is saying is and if you kind of recall from our description at the beginning of this learning module with going through and looking at the compilation process, right? All of those steps along the path. One of those is the linker step, right, where we're actually trying to basically take some code that we've written and combine it with other code that's been written in, say, some other library. Okay, this warning is an indication that it cannot find the declaration of that function in another library. Okay, but it compiled our version of the code, but it's saying it's having trouble connecting it with another library. It doesn't know how that function is defined. All right, so you don't want to run it if you see a warning like that. You want to address the warning directly. Okay, so you don't want to ignore the warning. I can show you how to get rid of it. Okay, so the way you would get rid of that warning is to actually go here and include the correct library. Okay, and the correct library in this case is actually string.h. If I go ahead and do that and go back to the terminal here, you'll notice that and it might actually also need the standard library. Okay. So that error is indicating that it's missing a library, okay? It needs to have the correct one to be able to, know the function declaration, right? The inputs and outputs. We're going to do that and the error went away. Okay. So treat warnings seriously. Okay, so that's how you can take a string, convert it to an integer. Right, we could also go and we could change this to a float, right? A2F would be a float, right? And I could go ahead and convert the string to type float, right? Pretty simple changes here, be %F to indicate that we're printing a float, right? And I go ahead and I can do that. Okay, printing a float. Okay, if I wanted to enter a double, the way you usually do that would be to actually convert a string to a float and then take that floating point, make it a double, and you can actually just go like this, right? Because the double will take precedence, right? Floats actually double the precision, so you're not going to lose any data doing it that way. You're not going to run into a compiler warning or anything. I could just make this display long float and go ahead and change that to printing that double, right? So we can do that as well. Save that. Then we could see down here, compile, let's run it, and that works fine. Okay, so that's just doing some of the string comparison, some ways of basically converting from string to an integer to a float to a double. Okay, very common to want to do that. The reasons you typically do that is you're reading a string from a file, you're reading in a string from the command line, you're reading in a string that's entered from a user, any host of different ways of getting this data, right? So you have text data, but you know and you're expecting it to be numbers, right? And you need to basically, to be able to perform those type of arithmetic operations, those mathematical operations, you're going to want to be able to take that string character type and convert it to the proper numeric character type. Okay. Usually you want to perform standard error checking in here too, make sure that the data that you're getting is what you're expecting, so that you don't end up having erroneous values coming in that are going to be messing with your calculations. Okay. Okay, so let's, it might make sense for you to watch this video multiple times to help you get through and understand the basics. I highly recommend pulling up the C environment, writing some code yourself, experimenting, printing some things out to the terminal, right? That's the way you really learn, is by writing code, making changes, messing with it. You keep doing that, you'll get good pretty quick, okay? So it's important to be trying these things out and running it yourself. That'll really let it stick in your long-term memory, okay? The next video we'll look at command line arguments. which is a pretty important topic, and that has some data type conversions kind of embedded in how to kind of manipulate and use that data that we get from the command line. And we'll talk about that in the next video. All right, so thanks for watching. Bye.